A three-legged stool is subjected to the load P as shown. If the force P is equal to 200 newtons, compute the following: the reaction under leg A, the reaction under leg B, and the force reaction under leg C. And to solve this problem, we set up our reference axis. So let's take Z to be vertical, going upwards, and the x-axis that is parallel to the line connecting B and C. And the y-axis going in this direction. So there is a normal force due to the surface and the weight of the three-legged stool that would induce a normal force of N sub A at point A, N sub B at point B, and N sub C. By taking summation moment along the y-axis equal to 0, considering clockwise to be positive. But first, we need to solve for the radius of this bigger circle, which has a length of 100 plus 75 plus 75, that is 250 units. That is the radius for this bigger circle. And then, by taking summation moment along the y-axis, we have the normal force at B times its moment arm distance of the radius of 250 multiplied by the sine of 120 degrees. So this is the moment arm distance of N sub B along the y-axis, minus the force of N sub C that would induce a counterclockwise rotation. So its moment arm distance is the same, that's 250 sine of 120 degrees, all equal to 0. Now by factoring out 250 sine 120 degrees, we can cancel these two factors here, leaving us by N sub B minus N sub C equal to 0. This is by dividing 250 sine of 120 on the equation. So here you can see that N sub B is equal to N sub C. This serves as our first equation. After that, we can take summation forces along Z equal to 0, considering upward to be positive. So we have N sub A plus N sub B plus N sub C minus the downward force P of 200 Newton equal to 0. And this serves as our second equation. For our last equation, we take summation moment along the x-axis equal to 0, considering this rotation, which is clockwise, to be positive. So we have a 200 Newton force, which is force P, times its moment arm distance of 175. That will induce a clockwise moment, so it's positive, minus the moment induced by N sub B, since that will induce a counterclockwise moment, so it's negative, times its moment arm distance, which is equal to 250 plus this distance here from here, that is 250 cosine of 60 degrees, because since this angle here has a total value of 120, halfway this angle, that's 60 degrees, and this one here is also 60 degrees. So minus another moment induced by N sub C, which is counterclockwise, so it's negative, times its moment arm distance of 250 plus this distance here, which is equal to 250 cosine of 60 degrees equal to 0. So we have three equations with three unknowns, enough to solve this problem. So let's rearrange this. We have our first equation, N sub B equals N sub C. So this becomes N sub B minus N sub C equal to 0. And for the second equation, that's N sub A plus N sub B plus N sub C equal to 200 newtons. And for the last equation, we have negative n sub b times 250 plus 250 cosine of 60 degrees minus n sub c times 250 plus 250 cosine of 60 degrees equal to the constant term of negative 200 times 175. Now we can input these three values to our calculator by going to mode 5, 2. So three equations with three unknowns. We let A represent the normal force at A, and B for n sub B, C for n sub C, and for the constant term at D. So we have, for the first equation, we have no n sub A, we have 1 n sub B, and negative 1 for n sub C, and no constant term. And for the second equation, we have 1 n sub A, n sub B, and n sub C, equal to 200. And for the last equation, we have no n sub A, and then for n sub B, that's negative 250 plus 250 cosine of 60 degrees. And this has the same value for n sub C. So that's negative 250 plus 250 cosine of 60 equal to the constant term of 200 times 175. We get our final answer, that is n sub A, which is equal to 320 over 3, or approximately 106.67. This is in newtons. And for n sub B, which is just equal to n sub C, based on our first equation. So it has the same value of 140 over 3, or approximately equal to 46.67. And these are our final answers.